Hello students, I think I am audible properly and my screen is visible. Please give a thumbs up in comment. Okay, so welcome to the second lecture of digital logic. Today we will talk about Boolean algebra, that is one of the topic, and logic gates. Okay, so before that, how is your preparation going? I think everything is going right. Good evening all. Please confirm in the chat. Yes. Okay. Okay. So welcome, get aspirant. So without any delay, let's start our today's session. And before that, best of luck, all of you, for GATE 2023. Okay. Okay. So this is I think most easier one, and these are some basic formula. You already know that x and x is x, x with x and x bar is 0, x and with 0 is 0, x and with 1 is 1. Like this OR operation, if we do x plus x is x, x plus x bar is 1, and x plus 0 is x plus 1 is 1. So these are some basic rule of Boolean algebra, and I think you don't need any explanation in this. If you need, you can comment it. Okay. So and plus, and that is and or both follows commutative law. Okay, x and y equals to y and x plus y equals to y plus x. Associative law, it is also followed by both and or operation. Just a minute. So now let's see some of the important formulas. First one is distributive law. OR is distributive over and and vice versa. Okay, both way it is true, and vice versa. Okay, OR is distributive over and is distributive over OR. Now this is one of the important formula. Okay, that may not be like that, you may neglect this formula in the equation. Like when you got an equation like this, xy plus x bar z plus yz. Okay, in this stage you can see, you may think that you cannot solve this further. Okay, look at this formula. Okay, if you take y common, it is x plus z. So you may think that, but it can be more solved and it can be more reduced to xy plus x bar z. That means if x is present in non-complement form, x bar is present in complement form, and the multiplication, that is y and z, is present separately here, then you can discard this whole thing and you can directly write x dot y plus x bar dot z. Okay, this is a very important formula, that is called consensus law. Another one is same thing, just replace with plus. Okay, x plus y, x bar plus z. X is present in non-complement form, x is present in complement form, and these two terms, that is y and z, which is present with addition with them, they are present separately here. So you can discard this. You can write x plus y into x bar plus z. Okay, now De Morgan's law, it is also important, but you may know this. Okay, that is x dot y whole bar is x bar plus y bar, and x plus y whole bar equals to x bar dot y bar. Another one is absorption law also there. Okay, which says x plus x bar y is equals to x plus y. This formula is also important. You have to just sometime you have to just look at this formula and you can solve many problems using this absorption law. And this same is applicable if you replace plus with dot and dot with plus. Okay. So let's solve some numerical, solve some Boolean formula. Okay. Before that, let us prove why consensus law is true. That is xy plus x bar y, not y, that is z, plus yz. Now I am claiming you can neglect yz. Let us see why. It can be written as xy plus x bar z plus x bar into yz, because x plus x bar is 1. So you can multiply it with yz. So your equation become xy plus x bar z plus xyz plus x bar yz. Okay. Now now what you can do, you can from these two you can take common what, xy you can take common. So what left, that is 1 plus z, and also do the same from this and this term. So you will have x bar z with common 1 plus y, which is equals to xy plus x bar z. Okay, so look at this term, xy you have here, x bar z you have here, but this term is no more here. Okay, so okay, let's solve some questions on this. This is the most easiest one, I think. So anyone want to give it a try? Just anything, anyone? Okay, you can do it here directly, like it is not very a complicated question. Okay, it is a easier one. You just read about this, just apply consensus law. Okay, which term you can vanish out, you can vanish AB term, because you have C bar, and what is this coefficient with C has B, C bar has A, and both are present in plus form. So directly using consensus law, directly you can write it as AC bar plus BC. Yes, right. Fine. This was the easy one. So let's come to this. So you are given a Boolean expression for f, which is equals to pq plus p bar qr p bar qr bar s. The minimum SOP form of f is which one? This is, I think, a kid previous year. If you have any doubt till now, okay. So I'm solving this. So if you have any doubt, you can query. Okay. PQ plus P bar QR, P bar QR P bar Q R bar S. Okay. So when you look in these two terms, you can see you can take Q as common, and what you will left with is P plus P bar R. P plus P bar R. When you look at that, the first thing will strike in your mind is absorption law. Okay, so this is the same term you have here. So it will be P plus R plus P bar Q R bar S is QP plus QR plus P bar Q R bar S. Now here you can directly cut this. Okay, like look at this term QP, and here Q. If you take Q common, you will left with P bar R bar S bar. Okay, so P bar you can cancel out is by absorption law. Okay, P bar you can cancel these two. From these two, if you take common, you can cancel it. So your expression will be QP. I am writing it directly. Okay, plus P bar will no more there. Will be no more there. Now, if you from these two, if you again take Q as common, okay, if you again take Q as common, you will left with R plus R bar S. So your R bar will be cancelled by absorption law. Plus QS, QPQ plus QR plus QS. So A is the correct answer. Anyone having any doubt in this? Okay. So these are some easy questions. So we are going a little bit faster here. Okay. So if you find any doubt, any problem, if you want me to go a little bit slower, you can tell me that. Okay. Okay. So let's solve this. You have P plus Q bar, PQ bar plus PR, P bar R bar plus Q bar. Okay. Now don't just go for multiplying now, because it will be a very big term. So look at here. You can take P common from here. Okay. So you can take P common from here. Now where will you multiply this P? You can see here is a P bar. So if you multiply P here, you can cancel this P bar. That's why take common that P from here. So here you will have Q bar plus R. Multiply that P directly here. Okay. Plus PQ bar. Okay. Any doubt till now? Not R bar. So since you have multiplied P with P bar, your result will be 0. So you can multiply this with this one, because here you have P and Q bar both. So if you multiply, you will have PQ bar plus PQ bar into Q bar plus R, which is equals to PQ bar plus PQ bar is equals to PQ bar into Q bar plus R, and if you multiply it again, yes, this is official channel. Uh, this is official channel only for GATE. Okay, so it is official channel for GATE Computer Science. p q bar plus p q bar r. If you again take common p q bar, 1 plus r will be left. Okay, so you have p q bar. So there will be not any r because 1 will be added with r and it will result 1. Fine. Okay. So any doubt? Okay, I am Bengali. Okay. So now let's simplify. Okay, simplify this expression. This is not a very difficult one. You can look at this and directly we can go forward with this question. Okay, a plus a bar b plus a bar b bar c plus. Now look at this here. A bar is common, b bar is common, c bar is common also. So a bar, b bar, c bar, if you take those as common, you will left with d plus d bar e. Okay, okay. So now look at here, d plus d bar e, it can be simplified to directly d plus e because of absorption law. Okay, a plus a bar b plus a bar b bar c plus a bar b bar c d plus a bar b bar c bar e. Okay, so again between these you can again take common a plus a bar b plus a bar b bar c plus c bar e d plus e. Okay, if you again take this as like using absorption law, you can directly write it as a bar. Yes, yes. So yes, you have got that trick. You are every time you are getting one sum product. Okay. So directly you can write this type b plus c plus d plus e and a plus b plus c plus d plus e. Okay. So no, I am not in IIT Bombay. I am in IIT KGP because it's near to my house, near to my city. So I have choose IIT KGP. So anyone having any doubt? Okay. So let's go to the next one. This is also a very easy one. Okay. Just solve this and tell me the answer quickly. Okay. Now here I can take common from here. Okay. So what will be left? Xz. Okay. Again, again, again. If you have xz here, okay. Anything you can forward with. You have this till now. Any suggestion? That doing masters in USA is better than doing masters in India. Uh, Possibly in terms of placement, obviously, maybe there will be some better opportunity for you. So if you can afford that, so yeah, this is better. So any idea how we can forward further? So we can take x common from these two again. In that case, what will happen? We will get absorption law. Yeah, yes. So this z bar will be cancelled. Again, anything you have xy bar. No, that is xy only. Okay, xy and xz left. Okay, if you can take again y common from these two, you can cancel this x bar. Okay, again anything else if you take common from here, if you take common, no, you cannot take. Okay, so yeah, you have these two, third one and first one. If you take common y again, okay, you can cancel this x bar by absorption law. So we are doing this directly. Okay, so yeah, let us write it, what we left with. So yz bar plus y bar z plus xy plus x plus xz. Okay, so anything from here we can do. So I think if we have forwarded by taking common from these two, it would have been much simpler, no? Because you have y z bar to take common. Okay, so let's come from here. Okay, y z bar plus simply you can take common y bar z, y bar z plus xyz. No? It is much simpler one. So if you take again z common from these two, you can, so if you take z common from these two, you can cancel this y. Okay, x, I think no, let us solve this. Okay, uh, xz plus y you are saying. Okay, let us see. So you have yz bar, y bar z and xz. Okay, I think this is the simplest one. Okay, this is what I have, simplest one. So you are saying x bar, y bar z, x bar z bar y. Okay, okay, you are saying is it correct or not? uh, so okay, no, I don't think this is correct. Okay, this you cannot eliminate 2 directly. Okay, so if you have xz here and you have x bar, z bar, y here. Okay, if you want to eliminate, what you are doing, you are eliminating this whole term. So not of this should be present here. Okay, so not of this, that means x bar z bar not, which is equals to x plus y. So this should be present here, x plus z here. Okay, x plus this should be present here, only that you can cancel like this. Okay, fine. Okay, so if you don't have any doubt, let's go to the next question. Okay, okay, that is a very like brave thing to answer. I cannot say what will be in your future, but if you talk about Internet of Things in India, maybe it is little bit far. Okay, it has future obviously. In abroad, it is already using. Okay, but in India, it will take little bit more time to come. But still I cannot like comment it, this will be happen for sure. So yeah, So look at this, this binary operation is given to you. Okay, what you have to tell that s1 and s2 which are true or false. Okay, now look at this, this is nothing but NAND, this is nothing but NAND, because x bar plus y bar can be written as xy whole bar. So we know NAND does not follow associative law, but NAND follows commutative law. Okay, you can directly write this, okay, by identifying the gate. Otherwise, you can also solve this. Okay, you can write P hash Q as P bar plus Q bar, and then again perform hash with R. Okay, so I don't think you need like this solution. Okay, you can directly using the property of NAND, you can write this. If you want me to give the solution, the broad solution for this, you can comment. Okay, you can just simply put the values and look at it. Okay, it will be easier. So okay, let's do this one. What they are saying, that find complement of the following expression, okay, and simplify it. So they are asking you to first complement and then simplify it, but you can do it by reverse. Okay, first simplify it, then do complement, because if you do complement here it will be a bigger equation, and maybe if after applying De Morgan's it may be tougher for you to solve. Okay, so first let's simplify it. Take AB as common. So AB, C plus C bar is 1. So you can directly eliminate that. And here you have A bar and C as common. A bar and C as common. Okay. This is as F, which was given. Now you are asked to find out F bar, which is equals to AB plus A bar C whole bar, which is equals to A bar plus B bar into A plus C bar by De Morgan's law. Okay, so if we multiply this A with A bar, which is 0, plus AB bar plus A bar C bar plus B bar C bar. Simply this is 0, so you can neglect this one. Now can we simplify this much further, or is it the final one? Anyone? If we can solve it further, tell me how we can proceed with this. Yeah, right. So you have a bar, and B bar and C bar is present here. So apply consensus law. A B bar plus A bar C bar. Okay. So fine. Anyone having any doubt? Okay. So let's go to the thing. Next last question from Boolean algebra. Okay. You have to simplify this expression. Let me write it here. This easier one. Okay. Plus B plus C bar. The whole has a bar. Write it like this. Okay, so you can open this bracket simply. Okay. A plus B bar plus C plus D bar plus B plus C bar, and put the whole bar here. So B plus B bar is what? 1. B plus B bar is 1. So 1 plus anything, okay? anything that will be 1. So you have 1 bar which is 0. Okay, fine. Okay, fine. So let us start with another important topic, that is logic gates. Okay, before that, okay, I think you all know that GFG has this time a test series, okay, and we are already like launching a test every day. We are working with this test, okay. So you have 22 subjective tests, 10 full mock tests, subject-wise short notes will be there, which can be very important in December, January time, okay, for you, which is curated by IITians, and this is all India mock test. And if you look up, compare it with other test series, you will find this much pocket friendly. Okay, how to remember laws? Remember is just uh, come here. You just can, what you can do, you can uh, some try to memorize. If you cannot, sometime you can, for important one, okay, like consensus, okay, de Morgan's, those I would recommend you to memorize, okay. Otherwise, if it is a small thing like x dot x, x plus x bar, if you forget these formulas, these are simple, just put some value and look at this, okay, what is happening. Just put x equals to 0 and see the multiplication is 0. Put 1 and multiplication is 1. That means multiplication is always equals to x. So like this, take example. Okay, if it is a small formula, that basic formulas if you forget it. Otherwise, those tough formulas, that is consensus one. So these formulas I used recommend to memorize. Okay, direct. And solve more question. I think you will able to memorize all these. So basic gets, which is really basic, that we are learning from class 10 maybe. So yeah, AND gate. This one is AND gate. You had input A, B, and output is, let's say, C. So I'm going faster here. Okay. If you face any problem, you can comment it. I will explain further more in details. Okay. So AND gate is, if you have at least one zero, okay, at least one zero, your output will be 0. Okay, these are easier, obviously. Okay, important thing is these are easier but important. Okay, but important. This easy concept can be made very tricky in the questions. Okay, so be very much clear about this one. So just not only the gate, how it works, that statement you also have to memorize, that is at least 1 0, results 0. So this is the main statement that you have to memorize. Okay, here at least 1 1, results 1. If you have at least 1 1, that means your addition, that all result will be 1. Not get, so this is the not get one. So let me draw it here. So that is a reversal of your input. Okay, if you have 0, you will have 1, 1 will have 0, A and B. Okay, so these are about basic gates. Now come to universal gate. So you know why it is called universal gate, because we can make all of the basic gate from any one of these, using any one of these, like using NAND or using NOR, you can make all of three, and all, and or and not to get. Okay, so how does it look? NAND gate is like this. Okay, so nothing but you are multiplying first. Okay, that means you are performing AND first, and you then you are doing a NOT. Okay, so if at least 1 0 is there, then output will be what? So if there is at least one zero, your multiplication result, that means I am saying multiplication, but it is actually AND operation. Your AND operation result will be 0. So your output will be complemented. So it will be 1. Okay. Same way for NOR gate. If there exists at least one 1, then the addition result, that means the OR result will be 1, and the NOT gate will make the output as 0. Okay, 0. Fine. So let's just take just one example and we just convert using NAND gate. We build each of these three gate. Okay, NAND, using NAND we will first make AND gate, which is very easier. So you see NOT of AND here. So just take two input A and B, pass it through the NAND gate. Okay, what is your result here? That is A dot B whole bar. Okay, NAND gate, and then again complement it. To complement, just again pass it through NAND gate. Okay, so your result will be A bar dot B bar, again dot with this and whole bar. Same expression is multiplied. X dot x is x, which is A dot B whole bar, which is equals to A dot B. Okay. Now NAND to OR. How to do this? First complement each of these input. Okay. First complement each of these input. That is, you have A bar, send B like this, and you will have B bar, and then send both here again. So you will have A bar dot B bar whole bar. Okay, which can be simplified to by applying De Morgan's law as A double bar plus B double bar, which is equals to A plus B. Okay. Now NAND to NAND to NOT, which is another one. This is easier one, so you can directly send it here to perform NOT operation. Okay, the way we did it here. Okay, so I think this is clear. You don't have any doubt in this. So now this is the most important gate for gate. Okay, so this is the most important gate for your gate, because many questions come from XOR and XNOR itself. Okay, so how does it look? Okay, draw it like this. Actually, you can draw it much better than me. So okay, so A B and A XOR B is the output, which is can be simplified, which that is a simplified form is A bar B plus AB bar. Okay, let me write truth table also for this one. Okay, so 0 0 0 1 1 0 1 1. So result can be 0 1 1 and 0. Okay, so it outputs 1 if odd, odd number of 1 present in input. Okay, So yeah, let's do XNOR. XNOR is nothing but the complement of this one. Okay. Okay. A XNOR B, which can be again written as AB plus A bar B bar. These two together completes the mean term of two variables. No? AB, A bar B bar. Here you have A bar B and A B bar. So AB 0 0 0 1 1 0 1 1. So your output is 1 1 here, and here you have zeros. Okay. So outputs 1 if what, if you have even number of zeros. Okay. So this type of question are very common for GATE exam. That is, you will be given any expressions, and you may ask to build this expression using NAND gate, and they will ask how many minimum number of NAND gates are required. Okay, minimum number of NAND gate. So let's say we are building XOR gate using NAND gate. Okay, so we note the expression for XOR gate, that is A bar B plus A B bar. Okay, fine. So let's do it. A bar B plus A B bar and A bar with this and B B bar with this. So this will make no difference because A bar is 0 and B B bar is also 0. So adding 0 makes no difference. So take common B from this one and this one, and take common A from these two. Okay. So you will have A bar plus B bar. Okay. Plus here if you take A common, you will again have A bar plus B bar. So when you look at this, you can identify this is one of the NAND gate, because you can write this as B into A B bar. Okay, this is the NAND gate expression, A B bar. So now what we can do, we can put two complements here. Okay, let's put two complements. Okay. Okay, so you will have B A B bar, and you can divide it between these two, A B whole bar, and here is another bar, and you have a whole bar here. So look at this. This is one of the NAND gate you are using, and the result is again sent to another NAND gate. Okay, and those two result again sent to another NAND gate. So how many NAND gate you are using? One is here. So the same you don't need to again apply here NAND gate, because the result you can use here. These are the same expressions. So again there is another one, 2. Here is another one, 3, and here is another one, that is 4. So you need 4 NAND gate. Okay, fine. So if you have any doubt here, okay. So let's just use same expression, that is the same circuit, for building XNOR gate using NAND gate. Okay. So let's say you have A and B. You know the circuit how to make XOR with NAND. Okay, XOR using NAND. Okay, so the output you will get will be A or B. Okay, and you will need four NAND gate here. Okay, and here you can send another NOT gate, and so that NAND will complement this output and the result will be A dot B. Okay, that is the XNOR one. So how many total gate you are needed to do this? That is 5. Okay. The same work you can do using NOR gate. You can build XNOR and XOR. Let us see this. So if you use NAND to build these two, to build XOR you need 4 gate that we just saw that one, and using NAND you can build XNOR that will require 5 gate. And the reverse is this, that if you are using NOR gate to build XNOR you will require 4 gate, otherwise using NOR you can build XOR using 5 gate. Okay. This table you should memorize it. Okay, also you look at this proof, understand this proof, but also it is important to memorize these things. Okay, so let's look at this question. The output of a logic gate is 1 when all inputs at logic is 0. So what can be the gates? Okay, so anyone can come up with this answer. I think this is a gate previous year question. So anyone, see, you are saying that is AND. For AND you are saying for AND output logic is 1 when all inputs are 0. I don't think so. When all in, if at least one is 0, then AND output will be 0. So C is not the answer. We can delete this one. Okay. So any other? When all inputs are 0, that means you can say the OR will be, if all are 0, all inputs are 0, then OR of all them will be 0. That means NOR of all them will be 1. Okay, this is one of the gate that we got. So B and D can be answered, and A, look at A. So they are saying XOR. Okay, if all inputs are 0, then what is the output of XOR? Output of XOR is also 0. So you can discard A also. Now you have these two. Okay. Now you have discarded this for XOR. So you can discard this again for XOR. Okay. That means XNOR is left. So you can try it. If when all are 0, your output of XNOR gate is 1. Okay. Fine. Because you have even number of ones. Okay. Okay, so if you have any doubt, you can comment, or let's solve this one. Okay, output, the output Y for this logic circuit. What will be the output? Okay, so for XOR, always remember this property. Okay, if you XOR anything with 1, what will be your result? If you cannot remember, like you don't have to memorize, you can check it. XOR 1 with 0 results 1. So 1 XOR with 0 results 1, and 1 XOR with 1 results 0. So look at this. What you are giving input, you are getting the complement one. Okay. So 0 XOR with X. Okay. A you are saying. Okay. So we are, let us verify. So the result of 0 XOR X is 0 XOR 0 is equals to 0 and 0 XOR 1 is equals to 1. So which is same. So X. Now X or X, if both are same, your result is 0. If both are different, that is complemented, your result is 1. Okay. So you can memorize it or you can find it using examples, some examples. Okay. I would recommend you to memorize all this. Okay. So if you are you have a not get here, so you have x bar, x and x bar. So your output is 1. You say, okay, fine. Circuit shown below. The output F. What is the output F? So you don't have any option in this. Just tell me what can be the output. Okay. You can use those formula. So I got an answer. So let's solve this. You have x and x to the input of XOR. So your output will be 0 because both are same. Okay. Now you have again x from here and x XOR with 0 will have x again and x XOR with x will have you 0, which is your output. Okay. F is equals to 0. So let us solve some more question. I think enough. Okay, this is something little bit different one. Okay, so which gate is redundant? This is another type of question you will find in gate. Which of these, that is 1 2 3 4 5, which of these gate are or is or are redundant? Just write out the expression for if. Okay. And then for next questions. Okay, so let me forward little bit. You have W in the input, so output of this NOT gate will be W bar. You have Z here and W bar here, so you have W bar here, you have Z here, you will have W bar Z. Okay, so let us verify this. Z bar you have, X you have, Y you have, so you have Z bar X, Y, and you are adding all of this. So your if is W bar plus W bar Z plus Z bar X, Y. So in this tree, if you take W bar as common, you will have 1 plus Z bar X, Y, and this results 1. So your expression will become Z bar X, Y. Sorry. Okay. So if you compare between these two, you have your W bar, you have this term also, but This term is redundant. This term, from where you got this term? This term you got from get to. Okay, so get to is redundant. Okay, so let's solve another question. So, okay, I have to draw this one. So you have A, B, and a XOR gate. Have B and C, and again another XOR gate, and this C goes from another one. Sorry, F. Okay. So you are given that your F is 1, okay, given that your F is 1 and you have to find A, B, C. Okay, so kind of you have to backtrack your input from output. Okay, so it is easier one. So you know your output is 1 of AND gate. So AND gate output will be 1 only when all the input is 1. So you can use this fact to find out all these inputs. Okay. Okay. We solve this. Okay, let me do it here. And we can match our answer. So we will have 1, 1, 1 to all input of AND gate. Okay. So if this is 1, then here also your C will be 1. If you look at this word, so you got your answer for C, which is 1. Now output of XOR is 1. One input of C, that is 1. So what should be the this one? Okay. Now if it would have been 1, then 1 XOR 1 should output 0. But in the output you have 1, so it should be 0 or XOR 1. Okay. So it should be 0. So your B becomes 0. Now your B is here, that is 0. So but your output is 1. So what should be the value of A? So that your output is 1. Your value of A can be 1. 1 XOR 0 is 1. If you put 0 here, so your output of XOR will be 0. What you don't want. Okay. So your A will be 1. So the solution for this question is A equals to 1, B equals to 0, C equals to 1. Anyone having any doubt here? I think this was an easier one. Okay. Okay. So if you have no doubt, let's go for the little bit harder one. Okay. So you have A B which goes to the XOR, okay, which goes to XOR, and same AB goes to XNOR. Same AB goes to XNOR. Okay, and you have another one separately, that is C, which is coming here, and all three are going to again XNOR. Okay. Minimization, if you talk about K-map minimization, that will be covered in the next lecture. Okay. K-map you will have in the next one. Currently, we are minimizing by Boolean formula. In this lecture, we are doing minimization using Boolean formula. Okay. Using formulas. So, okay. Now it is given that your output of f is equals to 1. Okay. Then what will be your inputs? Now try this one. Okay. 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 So let us forward with this. First thing you have to analyze that your output of XNOR is 1. That can be possible if you have even number of ones here. Okay. So you will have even number of ones here. Okay. Now you can see it is A or B and it is A XNOR B. Okay. Now these two output cannot be same. Huh? One is complement of another. One is complement of another. So if this is 0, then this would be 1. If this is 1, then this would be 0. If this is 0, then this would be 0. Fine. So that means both of the cases, what is the similarities? You are having only one, but you need even number of ones. So that means you can be sure here that your C value will be 1 obviously to get even number of ones, because these two both cannot be 0. Both of these two cannot be 1. Okay. So you have 1 here. Okay. Now this can be 0 or 1 and 1 or 0. Fine. If it is 0, if A or B is 0, okay, that means your A value and B value can be 0, 0. Okay. If it is 0, 0, then your output of XNOR is 1, and so this is what you are getting. It is satisfying. Okay. The same way, if you take 1, 1, okay, then also your value is satisfying. Okay, 1 or 1 is 0 and 1 XNOR 1 is 1. Okay, so you are again getting this one. So your A equals to 0, B equals to 0 and C equals to 1. It is what satisfying, and both can be 1 also. Now, is there can be 1 0, another is 1? Yes, okay, this is also possible answers. Okay, but you will have your options. So, in the GATE examination, you had this option, and there is only one option where C equals to 1. So, that is what you have to identify here. C will be 1. By identifying, you need even number of 1, and you cannot get even number of 1 from these two outputs, so your C will be 1. Okay. Okay. So now let's this one. So you have a XOR gate, and you have output. Again you have a XOR gate, and let me write another input here. So you have one, second XOR gate here, and output. Like this goes on to another XOR gate, which is 28 XOR gate. The output of this is it's a y. Okay, and this is x, this is y. What will be your output at y end? What will be your output at y end? So this is the question. But let us solve some more. We find some more interesting questions here. Okay, so let us solve this. 1 and x, you are doing XOR. So XOR x with 1 will result x bar, and then x bar with x will result again 1, and then 1 with x again somewhere result x bar. Yeah, like this it will go on. But the similarity is, if you are coming out from an even number gate, your output is 1. So from the 28 gate, your output you will get will be 1. Yeah, the easier one. So uh, do it some little bit different type of question, that is minimum number of NAND gate question. You are given an expression y equals to a plus bc, y equals to a plus bc. The question is, how many minimum number of NAND gates are required? Okay, this is still easier one. So let me solve this one, and the next one I will give you time to solve. Okay. So what we can do? We can do complement. So what will be our aim is to convert this plus to dot, because we need and. So that's why to get to De Morgan's law. Okay, using De Morgan's law, we can convert this plus to dot. So you will have bar here and the whole bar. So a bar can be written as a dot a whole bar dot bc bar and whole bar. So how many NAND gate you are required? 1, 2, and 3. So 3 NAND gates are required. Okay, fine. Okay, now let's go to the little bit medium level question on this same concept. That is, you are given an output y which is equals to x bar plus y bar and z plus w. Solving this, I can give a hint. Okay, that is, remember how we made XOR using NAND. Okay. Consider you will find some similarity with this, but not totally. Okay. So try this one by yourself. I am giving time. Okay. So 2 minutes. I am starting the timer. Okay. What is the question? Okay, sorry. The question is how many NAND gate is required? The same concept we are solving. Okay. How many minimum number of NAND gate requires? This is an important concept I think in GATE. There has been I think 3 to 4 questions in previous year from this topic, that is to build using minimum number of NAND gate to build a expression, to derive an expression. So let me also find some new questions. Okay, last 1 minute. Okay, so let me go for the solution. If you are already solving this, you can comment it in between. Okay, we will match the answers. Okay, so you have here x bar plus y bar, which is nothing but can be built using one NAND gate, that you can directly say. So you can write it as xy bar into z plus w. Okay. Now here is one thing. Don't go for also making this NAND gate. Okay. Don't go for making this one as your NAND gate. Instead of what you can do, you can remember this concept how we have converted XOR gate using NAND. We have built XOR using NAND. So multiply these two. Okay. So you will have Z xy bar plus w xy bar. Okay. So these were some of like this type of expression you already got in XOR conversion. No? So applies same one, same concept. So apply double bar. which will result z xy whole bar w xy whole bar, and here is another bar. So is it clear? So you have one gate here, okay, that output can be reused here, and you have second NAND gate here, third NAND gate here, and you have fourth one here. So four NAND gate is required. So anyone having any doubt in this? Okay. Okay. So let's say you have a input A and B, and you have a gate, let's say G1. Okay. Now you are having C, D, another two input which are going through, sorry, which are going through OR and then NOT. That means NOR gate. You are going to again some G2 gate. Okay. And your output is Y, which is equals to, it is given that your output is AB plus C bar D bar. Okay. AB plus C bar D bar. So you have to identify which gates are these G1 and G2. Okay, you have to identify these two gates. So take 1 minute. It is a easier one. Just write the expression what you are actually getting using G1 and G2. Okay, by generalizing, and then compare with the output that is given. Okay, what you have to find, the question is identify G1 and G2 gates. Okay. Okay. So let me go forward with this one. Okay. So your if output is what you are getting. You are getting A bar here, B bar here, and you have C bar, C plus D. First you are adding, and then you are doing not operation. Okay, fine. So your if is A bar, it will having some operation, let's say G1 operation with B bar. Okay, and that will have some G2 operation with C plus D whole bar. Okay. Now this is equivalent to, this should be equivalent to AB plus C bar D bar. Now one thing you can suddenly identify, this is already there. That is C plus D whole bar. It can be again written as A bar, G1, B bar, some G2 and C bar, D bar. By De Morgan's law we have written. So this is already present here. So when you identify that, you can directly say what is G2. G2 is nothing but OR, so that you will have a plus sign here to match with this one. Okay. Now in some way, to perform some gate, to using some gate, A bar and B bar should result AB. Okay. This is what you have to identify. Now you know you have A bar and B bar. Okay, you have to make it AB. So if you plus them and not them, okay, if you first plus, we are doing addition, then not. By De Morgan, it will become AB. AB, okay. There will be whole bar. No whole bar you can like ignore, not whole bar. That is A double bar dot B double bar, which is equals to AB. Okay. This is what is needed in the output. So which gate you have applied here? One plus and one not. So that is nothing but your NOR gate. Okay. So your G1 is NOR gate. G2 is OR gate. So it is not about only the answer. Okay. So I am explaining like this because so that you understand how we should approach the question. Okay. Along with the solution, okay, just only don't see look at the solution, also understand how we are approaching to the question, because obviously this question is not going to come in your gate, but same type of some different question will be coming to your gate. So your approach should be right. Okay, the solution you will get. So is it clear, the solution and the approach both? Okay. So if it is clear, then we have the last question. Let's do this one. Okay, it is saying that is minimum. Good evening. Good evening, Jaskaran. I think I have spelled it correctly. Minimum number of gates, just NOR gates, okay, to implement f. What is your f? F is given as a plus f, a into a plus b into a plus b bar plus c. This is what you have to implement. Okay. Now, how many minimum number of NOR gate will be required? So directly don't go for finding number of NOT gate. First solve this one. I think it will, you can solve this one a little bit further. Okay. So first you can multiply all of this, or you can look at this. Okay, you can take A as common. Okay. So A, and take A common from both. So you will have A Okay, no, let's multiply this. So I think this will be much simpler one. Don't make it complicated. Let's. Okay, so AB bar plus AC plus multiply with B, that is AB, plus 0, that is BB bar, plus BC. Okay, so if you take common A from these two terms, you will have A. Okay, so you will have A plus, you are taking A common here again, so you are having A plus AC plus BC. B bar was there. Yes. Okay. So can you forward? What will be the answer now? Okay. So let us also multiply this A now. A plus. Now we can add these two A and your answer will be A plus AC plus ABC. Okay. So now if you take A as common, so your answer will be 1 plus C plus BC. So you have 1, which makes the whole equation 1, and your result will be A. So how many NOR gate you need to implement A? You already have all the inputs, so you need 0 NOR gate. Okay, 0 NOR gate. Is it clear? Okay. So, okay, let's go for another one question. Okay, let's go for another one question. So you have three AND gate. You have three AND gate, and the inputs to these three gates are, one is X, Y bar, and Z. Another one is W bar, X, and Z. Here you have W bar, Y, Z, and you are adding all these. Okay, addition of all this, and you are getting some F. You are given with gate numbers. You have to identify which gate is redundant. So the question is, which gate is redundant? Okay, that you have to identify. Okay, I am able to get 40 marks. Okay, without maths. So what you can do is that, talking about maths, I think you already have did maths in 12, 11. So I don't think maths will take too much time, and you don't have to go for whole maths. What you can do, you can just go for some important concept. Okay, to increase little bit marks. Let's say you can, if you can achieve like giving, if you can give one and let's say 2 to 3 days, and if you can get 4 marks, then why not? Okay, so give 2 to 3 days. Okay, and read important one like probability. I think there must be one question from probability. Okay, it's not only from maths, also some topic they also like make questions that is also like merged with probability concepts. So you just learn probabilities, it will take 1 day, solve some questions, get pyqs, okay, on probability. And also some important concept from maths. So matrix is a bigger one, so you can leave that. Whatever you feel comfortable. Okay, if you are comfortable with calculus, go for calculus. So I would recommend that go for probability, give 1 day, at least 1 day. So, okay, so 1 day or 2 day for probability, and then calculus or linear algebra, do whatever you are comfortable in. Okay, so yeah, I would recommend give 2 to 4 days to learn important subject, important topic, sorry. Okay, so you are already getting good marks. Okay, so if you can increase the marks, obviously I should say that you should make your chances higher. Okay, any answer to this question? Okay, so let us go forward with this one. What is your f? That is x y bar z plus w bar xz plus w bar yz. Okay, 2, we're saying 2. Okay, so let's verify this one. So z is common in all of them. Let's take it common. Xy bar plus w bar x plus w bar y. Okay, so you have y and y bar and y, and x and w bar is present separately here. So apply consensus law and your expression will be x y bar plus w bar y. So your solution is x y bar z plus w bar yz. So this term, and this is already present here in this term. Okay, so this is required, this is what you needed, but this is, yeah, not needed, redundant. Okay, so best of luck for all your exams. Okay, so yes, so we have a contest link. If you have any doubt, you can first ask. Okay, and also you have a contest. Okay, the link is given in the description. You can go and attend this that is that consent sorry, contest. Okay, so that is free of cost. So you can go and check it out. Okay, fine. If you have any question related to subject or out of the subject, you can tell me. Okay, fine. Okay. So I am ending the session here. Thank you all.